We're going to spend 2 days working with percents here. Today we're going to work with just a little background on percents. This should largely be a review for you, but we are going to buzz through some of the early topics and look at some applications. Tomorrow we're going to spend some more time on applications of percents, specific types of applications. A couple of things that we want to take care of today, though. First of all, I want you to be able to convert between fraction, decimal, and percent with no trouble. Those are basically the three forms that most numbers can come in, either a percent, a fraction, or a decimal. You should be able to switch between any of those forms with your calculator with ease by the end of the day. Also, most percent problems can be viewed as having three parts, base rate and percent. I want you to be able to identify the base rate and percent in any percent application or problem. And then, based on that information, I'm going to show you two methods for solving basic percent problems when you view the three parts of base rate and amount. Base rate and amount are the three parts. Now, here's a question for you. You've heard the word percent hundreds and hundreds of times in your life. What does it actually mean? Percent means per hundred. Cent, just like the prefix centa means hundred. Cent, 100 years in a century, 100 cents in a dollar. Percent literally means per hundred. So, when we say we've got 50% of something, we're saying we've got 50 per hundred. Now, a simple example of this is, let's say you had 7 out of every 10 students here at Western drive to campus. Well, if you've got 7 out of 10, that doesn't tell you what your ratio is out of 100, but you can set up a simpler proportion. If you're saying 7 out of every 10 drive to campus, then how many is that out of every 100? 70, of course. Yeah, that's just going to be 70. And that is the ratio that actually tells us what our percentage is. 70 out of every 100, or in other words, 70%. And of course, the way that that's expressed is not to always write it over 100, but basically just think of your percent sign as being a fraction bar with 100 underneath it, because that's really what the percent sign actually means. It means divided by 100. 70% of them actually end up making the drive. Now, what we're going to do with that in mind is the first thing we're going to do is just convert between fraction, decimal, and percent. Okay. All right, first one. We're going to start out with some very simple ones, and then we'll look at the cases that tend to trip people up a little bit more. First of all, 85% of people, not of people, just 85%. We're going to write that as a fraction in lowest terms and as a decimal. So 85% is what we're starting with. Well, for starters, write that as a fraction. Now, if we write that as a fraction, of course, you would write what? 85 over 100. Which is not in lowest terms. We haven't done any fraction work in here, but lowest terms mean that we can reduce that. What can we divide both the top and bottom of that fraction by? Yeah, and so this becomes 85 divided by 5, which is 17, and 100 divided by 5, which is 20. So 85% as a fraction in lowest terms is 17 over 20. Now, as a decimal, of course, you've got your basic move the decimal point rule, which we're going to see in a minute. But why does that work? Because 85% means that we've got 85 out of 100. 85 out of 100 can be written as 85 hundredths, or in other words, 0.85. That is 85 hundredths. So there you have your rule. If you have a percent and you want to change it to a decimal, what do you do with your decimal place? 2 spaces to the left, and it becomes 0.85. Now, a rule that I once heard that I kind of like, because people at all levels of mathematics still oftentimes, just not that you don't know it, but inadvertently make the mistake of moving the decimal the wrong way. If you're trying to get rid of a percent, you move the decimal away from a percent. You're trying to get away from percent sign, you move the decimal away, and that converts it into a decimal. So 85% is 0.85 or 17/20ths, and we've answered the question. Look good? Okay. It's a welcome change after what we were doing the last couple days, isn't it? 0.4% as a fraction in lowest terms and as a decimal. Now, these are the ones that trip people up. Percents less than 1, when you've got very, very small percentages, these are the ones that are easy to move the decimal the wrong way without thinking. Well, let's start out with the fraction. 0.4% will become, again, all you do is think of that percent sign as a fraction bar over 100. So we would write this as 0.4 over 100. But you can't have a decimal as part of your fraction, so we can just move it over. But what do you have to do if you move that decimal over? You have to move the decimal on the bottom over also, which means we have to tack on another 0. And so we actually end up with 4 over 1,000. Now, that is our fractional value. It's not, our 0.4% is 4 1,000ths, but it's not reduced. Divide them both by 4, and this becomes 1 over 250. So 0.4% is the same as 1/250th. And of course, if we write 0.4% as a decimal using our rule, we want to get rid of the percent sign, so we're going to move away from a percent, move the decimal away, and this becomes 0.004. We've written it as a fraction in lowest terms and as a decimal. We've answered the question. Okay. One more. Again, I tried to pick, other than the first one, I tried not to pick the easiest case. I tried to pick the cases that trip people up. Write 135 3/4% as a fraction in lowest terms and as a decimal. Well, for starters, let's take 135 3/4% and get rid of that fraction in there. Just write this as a decimal, or a percent with a decimal point in it. So this will be 135.75 is 75. So that's the same as 135.75%. Now, that's not the only way to answer this question, but this is how we're going to do it. 135.75%. Now, we're going to take that. We can write that as a percent by saying that this is equivalent to 135.75 over 100. We're going to move that 2 spots to the right, and what this becomes is 13,575 over 10,000. And now we're just going to reduce that down. Now you know without doing anything, you know you can divide these numbers both by what? Without thinking too hard about it. 25. You can divide them both by 25 because your last 2 digits divide by 25. And if you reduce that all the way down, you will end up with, anybody divide that by 25? 543. Now, if you didn't spot 25, you know you could divide it by 5 at least, and then after you've reduced it by 5, you could reduce it by 5 again. So 543 over 400. Now, that is a fraction. Unfortunately, it is improper. And so you remember how to take an improper fraction and make a mixed number? How many times does 400 fit into 543? Fits in there 1 time, and we're left with 143 over 400. Now, that's one of several methods that you could have used to accomplish that. That's consistent with the early examples. Now, the easy question is convert that to a decimal. 135 3/4% is 135.75%, what do you do to move that to a decimal? And that becomes 1.3575. And there they are as a decimal and as a reduced fraction, and we're done. I'm going to show you one more method to have handled this one that's a little bit harder to spot, but dramatically shorter. Okay? Another thing that you could have done here, I'm going to erase this middle step. We could have left it as a fraction and said that this is 135 3/4 over 100. Now, looking at this complex fraction or compound fraction, what could we multiply this whole number by in order to turn this into, this entire number by in order to turn it into a whole number? 4. Multiply it by 4, and that'll always get rid of any fourths, right? So multiply top and bottom of this fraction by 4. So on your calculator, type 135.75 times 4, and what do you get? 543. And of course, the bottom, 100 times 4, you have to multiply top and bottom by the same value, and you get 400. So that gets you there faster, but you have to be careful about how you're multiplying the top and bottom by the same number. Okay, well, if you're going to a percent, you move the decimal to the percent sign, towards the percent sign, or to the right. So, of course, 0.73, you move it towards the percent sign, which will make this 7.3%. Piece cake. Let's write the fraction 1 and 33/40 as a percent. Now, anytime you've got a value, a numeric value more than 1, what does that tell you about your percent? You're going to be more than 100%. The 135% example I had up here before, it was 135 3/4%, and it turned out to be 1 and some fractional part. It's going to be a numeric value, corresponds with a percent over 100. Okay, well, the easiest thing to do here is just to convert that to a decimal first. That's 1 point. What's 33 divided by 40? What is it? 825. 1 and 33/40, this is 1.825. Well, then you're home free. What's the percent here? Moving it towards the percent sign, it becomes 182.5%. Again, a number greater than 1 correlates with a percentage greater than 100. Now what we're going to do is we're going to look at a technique for approaching percentage problems. I'm going to introduce something called the base, the rate, and the amount. Any percentage problem can be viewed as having 3 crucial parts. You've got your base, the rate, and the amount. I like this example because it's nice and simple. Suppose 1 in 4 dentists recommend chewing on the cap of your pen. All right, well, there's 3 things there. There's 3 things going on. The first one is, we'll get to it in a minute. Ultimately, you could say that 1 out of those 4 dentists is 25%, right? That's a nice simple problem to think about. Well, the first part, your base is the full amount. In this case, that's the 4 dentists. On your quiz, that's the total number of points possible. If you're talking about a sale price or something, it's the original price. The base is the whole works. And almost always, whether you've ever noticed this or not, you will now, when you're dealing with a percent problem, the base value is almost always next to the word of if you're describing the problem. On your quiz, if you got 33 out of 40 problems, they're out of 40 problems. 1 out of 4 dentists. Of is almost always a tip-off to what the base of the problem is. It's the whole thing. Now, your rate is the percentage of that base that we're dealing with. And rate is easy to spot because it's always got the percent sign by it. That's the easiest one to identify. Your rate is always some part of the base. I accidentally have rate up there in the top left corner. I see now, a little too late to change it. But the amount is the numeric value that the rate represents. So in this case, the 25% of our 4 dentists is 1 dentist. So what would the rate be, what would the amount be on your quiz? The number of questions you got right. That would be the amount you're dealing with. The base would be the total number of questions, and the percent would be whatever your percent score is. And again, a linguistic cue, the amount is almost always next to the word is. And we'll see some examples of that in just a minute. Now, if you can identify, we're going to look at some sample problems here in a minute, but if you can identify the base, the rate, and the amount, there's 2 ways that you can use that. This is the less common of the 2 ways, but in general, it's always true that if we leave the rate as a percentage, that proportion always has to hold. Well, let's take a look at an example. What we want to do is spot the base, the rate, and the amount, figure out which one we don't know, because we always will know 2 of the 3 if it's possible to solve the percent problem. We have to know 2 of the 3. Either we're looking for the percent, the base, or the amount. Well, here's a very simple case. 375 is 15% of what number? Well, first of all, let's just identify the base, the rate, and the amount here. What's your rate in this problem? Do we know it? Sure it is. Your rate is 15%. That's always the easy one to spot. The base, do we know it? We don't. We don't know what that number is. Again, we don't know it. What number? So the base is what we're trying to find. And the amount, the portion of the base is our 375. So with that in mind, we can substitute into this proportion and solve. 15% over 100% equals the amount, 375, over our base. We'll just call that variable b. Now your percent signs ultimately cancel over here. How do you solve a proportion? Cross multiply and divide. Yeah, so we're going to multiply in this direction. We get 375 times 100. We get 37,500. That's equal to the same, whatever we get as a product in the other direction. In that direction, we have 15 times b, which is simply 15b. So 37,500 equals 15b. Of course, then you're home free. We just need to divide by 15. Anybody have that handy? $2,500? $2,500. Now, if you're thinking that's not how I'd have solved the problem, I'd agree with you. That's not how I'd solve the problem either. But that's one way to solve the problem. And that's based on the definition of percent per 100. And that works just fine. Okay. Now the rest of the problems we're going to use an alternative method to solve, which is a little bit shorter and generally a little bit more practical. And that's this. The thing to notice about the example that we just did is that we left that 15% as 15%. We didn't convert it to a decimal. Generally, we will. If you treat the rate as a decimal, 15% in that case would have been 0.15, then we could just use that relationship, that the amount is equal to the rate times the base. And that's the one that we'll use 95% of the time. Let's take a look at a couple more. And we'll use this technique to solve all the rest of them here. First of all, what is 37.3% of 420? Well, what's your base? 420, that's the full amount, and it's by the word of as it works out. So your base is 420. Your rate? 37.3%. Now, if we're going to use this technique where we just have the amount is equal to the base times the rate, we need to treat those percents as decimals. And so we should actually call our rate 0.373. And our amount, we do not know. So our amount is equal to the rate times the base. So our amount is equal to our rate, 0.373, times our base of 420. What'd you come up with? 156.66. Now we do need to address the sig dig issue here. How many sig digs can we keep? Again, we're just going to use the shortcut rule. Look at what your input values were. Find the one with the fewest number of sig digs. That's how many we can keep. Yeah, we're really only allowed 2 significant digits here, so we'd have to call this 160. Note in your homework that the text is a little bit inconsistent about whether it counts this 0 as a significant digit or not. Technically, it should put a line above it if it wants it to be significant. However, your text will oftentimes, on a number like 420, it will treat this 0 as significant. So when you're doing your homework, if you find out that you've got the right answer but the wrong number of sig digs, check that out as the possible solution, because it does that periodically. Base rate amount, which one are we looking for? We do not know the rate. We do know the base then. The base is which means our amount is 3.72. Again, your clue, you can usually just tell by the way the problem is stated, but 3.72 has to be your amount. It's next to the word is. Of indicates the base, and so of 455.6 is our base. And so we can use our relationship here and say that 3.72 equals the rate times 455.6. And of course, if you were just given this question, what most of you would probably do is divide 3.72 by 455.6. Well, that's what we're doing to solve this equation. So R turns out to be pretty small, 0.00817 are 3 sig digs. Don't make the mistake of writing 0.008. That would only be 1 sig dig. 0.00817. Now, that's our answer, but it does ask what percent, and so our answer is 0.817% after moving that 2 places to the right. And we answer the question. Well, anyway, floppies are pretty reliable. 0.32% of floppy disks fail when they're used. If that's true, how many of the 36,000 that a company produces in a batch are going to ultimately be bad? What's your base? 36,000. That was the full number of floppies produced. Your rate as a decimal, 0.0032, and we convert 3.2% to a decimal, and the amount is what we're looking for. So our amount is equal to the rate times the base, and so our amount will be 0.0032 times 36,000. Now, how many sig digs are we actually going to be allowed to keep here? 2. If you divide that out, you get 100 and something. 115.2. But we're limited to 2 sig digs, so we have to say that it is about 120 of them. They're probably going to go bad. This time our base is 12 volts. That's the full charge. Our rate, don't know it. Our amount, 3.90. Amount is equal to rate times base, so 3.90 equals our rate times 12.0. Divide both sides by 12.0. Those are volts, and they'll cancel off. .90 divided by 12.0, 0.325. 3 sig digs are all good, so we can keep all of them. 325, and so our answer is 32.5% is what's left. And that one's good to go. Look all right? But guess not. So anyway, if in 1996 it was $1.18, 2006 now it's around $2.64, what is the percent increase? Well, tomorrow we're going to work with percent change, percent error, a few applications of percent a little bit more. But you got to be a little bit careful with this one. So what is our base? $1.18, what it started at. When you're talking about a percent change, it's always based on what it began with. And so our base here is 118. Your percent change is always based on what it began at. Our rate, that's what we're trying to find. And our amount, what is the amount that we're talking about here? One word tells you the amount. The amount of the, starts with C, ends in E, in between our, thank you, change. It's the change. We want to know the percent change. So our amount is not 264, it's the change from 118 to 264. So our change was 264 minus $1.18. Our change was 146. That's the amount, because we want to know what the percent change was. If it started at $1.18 and would have gone up $1.18, then its change would be 100%, doubled in price. But our change is 146, so now we can answer the question. The amount is equal to our rate times the base. Therefore, our amount of 146 is equal to our percent change times the original value. That means our Percent change is the amount of the change. We're going to work more with that particular case tomorrow. Divided by 118. And your rate turns out to be 1 point what? 1.237. How many sig digs can we keep? 3. And so we have to call this 1.24. But again, we don't want that as a decimal. We asked for the rate, and so our answer is 124% was the percent change. Now, what does that 124% mean? If something has a percent change of 100%, for example, if I said today the price of gas is $2.50, there's going to be a 100% change by tomorrow. How much will it be tomorrow? $5. 100% change means it's going to double the starting value. So more than 100% change means it increased 100% and then some. It more than doubled, and that's what happened. That's counterintuitive. A common mistake is to think that if something doubles in price, that's a 200% change. That's not true. If I told you gas was going up 200% tomorrow, how much would it be? It'd be $7.50. That means it's increased by a factor of 3. That's a 200% change. Okay, last one. You thought that was the last one, didn't you? This is the last one. Aluminum gear weighs 7.14 ounces, and that's 28.5% less than a comparable steel gear. So what's the weight of the steel one? Well, base rate and amount. Tell me what you know. The amount is 7.14. That's right. Why isn't it your base? Because what's on? Yeah, the steel gear got reduced and left us with the weight of the aluminum gear, and so the base is unknown. That's right. So we know that the amount that we're left with is 7.14 ounces. Okay? We are looking for the base. And our rate? 28.5% refers to the amount of reduction. That's how much less it weighs. But the 7.14, your amount, refers to how much weight is still there. Okay? And so our rate is 100%, which is the weight of the steel gear, minus 28.5%. That means our rate is 71.5%. In other words, how much of the weight are we keeping? How much did the aluminum gear keep compared to the steel gear? Is 28.5% less, which means it kept 71.5%. Okay, so our amount of 7.14 ounces is equal to our rate, 0.715, times our base. And so our base must be equal to 7.14 ounces divided by 0.715. We can keep 3 sig digs, and so what do you come up with? 9.99 ounces. Now, how can you check that to make sure that that's true and that you've pictured your percent correctly? What's the quick check that you can make? Plug it back in. Take 9.99 ounces and multiply it by not 28.5%, because that's how much you lost, but multiply it by 0.715, because the aluminum one should weigh 71.5% of that. 9.99 times 0.715 is pretty darn close to 7.14.